In this lesson, we will look at the evolution of the atomic model. So we have to talk about what a model is so that we can understand what the evolution of it is. So a model is used to explain a concept that is sometimes challenging. So by comparing one thing to another, we can better understand it. So the early Greeks were the first ones that came up with a model for the elements. So they didn't actually do any scientific work, but they would sit around as philosophers and talk about what they thought made up what. So they thought that the four elements that were on the earth were earth, water, air, and fire. So this worked to explain the changes of state, solid, liquid, and gas. And for almost 2,000 years, this model was accepted. And Aristotle, a Greek philosopher, influenced many people through his writings of the four-element theory. Democritus was another philosopher, and his idea was the atom. So he actually took a rock and smashed it and smashed it and smashed it until he got to a little piece of dust, and he called that an atom because it could not be broken down any further. And he coined the term the atom, which comes from atomos, meaning indivisible. Atomos. Way later in the 1800s, John Dalton, who was a British school teacher, he came up with his own theory, Dalton's atomic theory. And his theory had 4 parts. It said that all matter is made up of small particles called atoms. Atoms cannot be created, destroyed, or divided into smaller particles. All atoms of the same element are identical in mass and size, but they are different in mass and size from other elements. And compounds are created when atoms of different elements link together in definite proportions. Another way to say definite proportions is same ratios. So elements link up in the same ratio every time. So for example, H2O, you always have 2 hydrogen atoms linking up to 1 oxygen atoms. In 1867, J.J. Thomson came along and he discovered a particle smaller than the atom. He said this particle was negatively charged. And he called them electrons. And since all matter is made of atoms, these particles, the electron has to be part of the atom. So he now proved that the atom is divisible, which was in contrast to Dalton, right? Because Dalton said that atoms cannot be created, destroyed, or divided into smaller particles. So by proving the atom was divisible, there was something inside of it, we now need a new model. So you could say why here. Dalton said atoms cannot be divided. So we need a new model. Thomson proposed a new model of this atom to help us understand what the atom looks like and how it works. So his model proposes that the atom is a sea of positive charge with negative electrons embedded in it, the raisin bun model or the plum pudding model. Sometimes it's even called the chocolate chip cookie model. The chocolate chip cookie model. So this is his atom right here. So he had, this is the positively charged pudding, and the electrons would be representing the plums in this case. Okay? So that was Thomson's model. Eugene Goldstein discovered another particle. And this particle, it behaved opposite to the electron. It was positively charged, and they were called protons. Sir James Chadwick discovered a third particle, and this was also smaller than the atom. It was neither negative nor positive. It was actually neutral and called the neutron. We still didn't have a new model until Ernest Rutherford. Ernest Rutherford, that's this guy here. Ernest Rutherford. And this was in 1912. He worked at McGill in Montreal, and he devised what was called the gold foil experiment, because he assumed that Thomson model was correct. So he sent positive alpha particles out of here, the alpha particles, and they were positively charged to towards a very thin sheet of gold foil. This is our gold foil. And based on Thomson's model, he expected all the particles to go straight through. But most of them did, but some of them bounced right back. So particles are coming back like this. A lot went through. So what did that mean? Well, that meant that the atom had a positive nucleus. So this is hard to see maybe, but this is a positive nucleus at the center. And the electrons were still whizzing around inside the atom. So he found the nucleus, in essence, through his experiments. Now, what would be the problem with this model? Well, if we look at it, we see that negative charges are attracted to positives. So the atom would implode on itself. So we needed a better model. And it wasn't long after that Bohr, who worked with Rutherford, he found that electrons were actually on energy levels. The energy level corresponds to an orbit for the electron. Now the electron can jump up and down from different orbits, and it loses a certain amount of energy called a quantum. This is something you learn about in grade 12 chemistry, quantum of energy. And we still use this model today. It's actually called the Bohr-Rutherford or Rutherford-Bohr model. So the nucleus, it's hard to see that little writing. I'll just write it again. The nucleus contains positively charged protons and neutral neutrons. And electrons are on the energy level. So all these little circles represent electrons. And it's also called the planetary model. Planetary model, because this is like the sun, and these are like the planets in their orbits around the Earth. And the electrons are negatively charged. Let's not forget that. So that's the end of this lesson. And some of the homework for this section you can do, you can read 5.1, and that's pages 179 to 186, and do page 183, numbers 1 to 4, page 184, numbers 5 to 7, and 186, numbers 6 and 7.